Hey guys, welcome to day 2 of learning about proofs. Today we are going to put some geometry into our proofs, as you can see from this first slide. Remember that proofs are just a step-by-step process explaining how you get somewhere. So in order to start my proof, remember all proofs start with what? So I'm going to go ahead and fill in my given. Typically, proofs will tell you what your given is. So this one says, my given says ray AB bisects angle CAD, and the measure of angle CAB is equal to the measure of angle EFG. Okay, so there's my given information. Now, anytime you see a word in your given, your next step should be to define it. So what word do you see in my given statement? So bisects should be my step 2. So this is definition of bisects. Okay, so think about what bisect means. Bisect means cuts in half. So if I look at my picture, AB is cutting this angle in half. That gives me 2 equal pieces. So what that gives me is the measure of angle CAB is equal to the measure of angle BAD. Okay. We are trying to prove that BAD is the same size as EFG. Okay, so I'm going to look, I've already used this first piece of my given, so now I'm going to look at this second piece. Okay, the second piece tells me that CAB and EFG are the same size. And we just said that CAB and BAD are the same size. So what I want you to do now is I want you to look at these two statements. What do you notice about those two statements? Okay, so if I look, I actually see the measure of angle CAB in both of those statements. So what property did we learn yesterday where if something is shared, we can make a statement from what's left? Okay, so remember syllogism was what we learned before, but we said transitive is the property that is like syllogism. So this actually allows me to make a statement from what's left. Measure of angle BAD is equal to the measure of angle EFG, which is exactly what we were trying to prove. A second example, you reflect a beam of a spotlight off a mirror lying flat on the stage as shown. Determine whether the measure of angle DBA and the measure of angle EBC are equal. So I'm looking at DBA right here and EBC, which is this one. Are those the same size? Well, if I look in my diagram, I actually have numbers for all of those angles inside, okay, all of those pieces. And angle 1 is marked congruent to angle 3. So those are already equal, these small pieces. Okay, so if I look at DBA, it includes angles 2 and 3. And if I look at EBC, that includes 1 and 2. And I know that 1 and 3 are exactly the same size. So if I look, both of these share 2, which has got to be the same. So for those of you that were asking when we would ever use that, angle 2 is congruent to itself. That's your reflexive property right there. Okay, and then I know that angle 1 and angle 3 are congruent. So yes, the measure of angle DBA is equal to the measure of angle EBC. Okay, that's just logical reasoning there. So determining whether something can be true or not is the proof. Why something exists. Why something happens. That's your proofs. Okay, my next proof says given AB is perpendicular to EF and CD is perpendicular to EF, I want to prove that the measure of angle 1 is equal to the measure of angle 2. So every proof starts with what? My given. So AB is perpendicular to EF and CD is perpendicular to EF. So if I look at my picture, AB perpendicular to EF tells me I have a right angle there. And CD perpendicular to EF also gives me a right angle. So think about this like a word in my given. So step 2 is going to be the definition of perpendicular. Okay, that tells me angle 1 is a right angle and angle 2 is a right angle. Okay, so I've used information from my given. Now if I look at my next statement, I've got some more words. What does it mean for something to be a right angle? How many degrees is that? So if I think about the definition of a right angle, that tells me the measure of angle 1 is 90 degrees and the measure of angle 2 is 90 degrees. Okay, so now I've used my statement number 2 in order to help me write statement number 3. Okay, so now I need to look at statement number 3. What do you notice about both pieces in statement number 3? Okay, so hopefully you see that both of them are equal to our 90 degrees. Remember, if they share something, then we can write a statement from what's left over. So the measure of angle 1 equals the measure of angle 2. And we just need to figure out why. So what property was it if we shared something, we set them equal? That's our transitive property. Okay, and if you need to pause at any time during this video, feel free to do so. Feel free to look through your notes from yesterday in order to help you out. We have 2 more proofs and then you guys will have your worksheet. Okay, my next one, remember every proof starts with your given. So I'm automatically going to say angle ALN is a right angle. Hopefully you're catching on. I have a word. So my step 2 is going to be a definition of right angle, which tells me the measure of angle ALN is 90 degrees. And now I need to look at my prove statement. My prove statement says I'm trying to get angle 1 and angle 2 are complementary, which remember means that they equal 90 degrees. So if I look at my picture, how do I get from angle 1 and 2 to the whole thing ALN? Think back, this is actually back in chapter 1. We used this, we came up with this. We said part plus part equals the whole thing. So this would be angle 1 plus angle 2 equals angle ALN. That is your angle addition postulate, AAP. Okay, now if I look at statements number 2 and 3, what do you notice that they have in common? You see that the measure of angle ALN is in both of those. So again, I'm going to use my transitive property. You guys will get used to seeing that one. A lot of the times proofs require the transitive property. This gives me that the angle of angle 1 plus angle 2 equals 90 degrees. You're just writing a statement from what was left. And if angle 1 and angle 2 are 90 degrees, look back at your proof statement. Okay, all I need is that angle 1 and angle 2 are complementary, which remember means that they add up to 90 degrees. So that is based on the definition of complementary angles. Okay, so lots of definitions, lots of postulates like your angle addition postulate, lots of use of transitive properties. Okay, this is a lot of times where people get confused with their proofs. Okay, last one. My given this time says AC is equal to BD. So I'm going to mark that on my diagram. AC is equal to BD. Okay, now I don't have any words in my given this time, but I do need to look at my picture. What parts make up AC? So what parts make up AC? So this would be AB plus BC equals AC. That is your segment addition postulate. So last slide we used our angle addition postulate. This time it's segment addition postulate. And we're going to use that same reason for part BD. So what parts make up BD? So I've got BC plus CD equals BD. Okay, now here's the tricky part. Okay, if I look, I can see that AC is in both of these. Okay, that's going to allow me to set what's left over equal. So that's these pieces if I'm using my transitive property. If you go straight to setting AB plus BC equal to BC plus CD, you are no longer using the transitive property, you are using substitution. Okay, so you're saying, I'm going to take this and I'm going to plug that in for AC. And I'm going to take this and I'm going to plug it in for BD. So there's two possible ways to do this proof. The shorter way is with substitution, but please make sure that you understand that that is substitution and not the transitive property. If you are confused by why that's substitution and not the transitive property, please ask me when I get back or email me. Okay, look at what you're trying to prove now. How different is my prove statement from my statement number 3? The only thing that's going on is I have these extra BC's in here. Okay, think about this if it were numbers, how you would get rid of those. So you're going to subtract a BC from each side. That gets you AB equals CD, and you used SPO. Okay, so don't forget about some of those other properties. They will come back up in your proofs. Think about definitions from chapter 1. Think about postulates. Use everything that you know in order to solve a proof. If you have questions, feel free to email me. Otherwise, work on your Intro to Proofs worksheet, and I will see you guys on Monday. Bye.